So we're going to start with this situation that I suggested here, where object 2 is at rest, object 1 comes in with a velocity v1 that is entirely horizontal. So all of our equations simplify a great deal. We get m1 v1 equals m1 v1 final cosine theta plus m2 v2 final x. And in the y direction, we simply have 0 equals m1 v1 final sine theta plus m2 v2 final y. So I can solve those. I have v2 final x is m1 over m2 times v1 minus v1 final cosine theta. And v2 final y is simply negative m1 over m2 v1 final sine theta. Now I will square each of these and add them together. Squaring the first one, v2 final x squared, final y squared. To help us keep it straight, I'm going to do this in blue, and then I'll do the other in green. So this will be m1 squared over m2 squared. They both have that. Now I have to square each of these terms. I have v1 squared minus 2 v1 final cosine theta. And then I have plus v1 final squared cosine squared theta. Now in the y direction, I add in a v1 final squared sine squared theta. And you'll notice the sine squared plus the cosine squared will just give me v1 final squared. Alright, so when we put this together, what we're going to find is that v2 final squared is equal to m1 squared over m2 squared times v1 squared minus 2 v1 final cosine theta plus v1 final squared. Alright, so that's our velocity 2 final in terms of v1 final, and the final angle of v1. Let's go to the next page.